Hello everyone, today in this video we are going to solve some problems on electric field. After this video you should be able to state and apply superposition theorem, and you should be able to solve numerical problems on electric field by applying superposition theorem. So let's do a quick recap to see what is electric field. There is a region around an electric charge where it can exert force on other charges is called electric field. Outside the electric field it cannot exert force on other charges. So by definition, electric field is force per unit test charge, and electric field is a vector quantity and its direction is same as that of electrostatic force. And this is the expression for electric field due to a point charge is equal to kq by r square. So this is similar to that of Coulomb's law, only we don't have the second charge out here. Other things are same. And unit of electric field is Newton per Coulomb. So from here we can write this. So basically electric field depends on the magnitude of charge and the distance. So for small charge we have small electric field, but if you take the large charge at the same distance we have more electric field, and the electric field is inversely proportional to square of the distance. That means if you go far away from the charge the electric field decreases. So as you can see out here we have strong electric field, but here the electric field is small. And if you keep a test charge out here, there will be large force on this charge because electric field is force per unit charge, and out here if you keep a charge the force will be less. Now this situation is similar to that of a fan. If you stand nearby the fan, air will be more, and if you go far away the air will be less. So this situation is kind of similar to that of electric field. Now let's understand the direction of electric field. So suppose I have a big positive charge, and if I leave a small positive charge here, and that will be our test charge. Test charge is the small positive charge. So the direction of force will be in this direction, that is towards the right. So this is the direction of electric field. And if you keep a positive charge in front of a negative source charge, then the direction of the force is towards the negative charge. So the direction of force determines the direction of electric field. So from positive charge it goes away and electric field goes towards the negative charge. So this is the very important concept you should not forget. Suppose I have a point out here, and suppose I keep a charge q1 here, then there will be electric field at this point due to this charge. Now if I keep another charge, then there will be electric field due to this also, and if I keep a third charge, then out here I have 3 electric fields. So what should be the total electric field is our concern. So we'll see how to find electric field due to many charges. So for this we use superposition theorem. So suppose we have 3 charges and point P. So out here I'm not keeping another charge as we have done in the case of electrostatic force. For electric field we need only one charge. So suppose these are the distance of this point from these charges, then electric field due to this charge at this point will be given by this expression. Similarly, due to R2 electric field will be this, and due to R3 electric field will be this, and these are the direction. Now I have got 3 vectors. Now I can add them using vector algebra. So according to superposition theorem, total electric field at one point is electric field due to all the charges at that point. Now let's derive the expression of superposition theorem. So using superposition theorem we can find the electric field at a point due to many charges. So superposition theorem can also be used to find the total force on a charge due to multiple charges, which we have already done in our previous videos. So according to superposition theorem, total electric field will be sum of all the electric field due to individual charges. So electric field due to Q1 can be written as this, Q2 can be written as this, and electric field due to Q3 at point P can be written as this. So now according to superposition theorem, we have to add all this electric field using vector algebra to find the electric field at this point. So if you use the expression of E1, E2, E3, you'll get this. Now if I have n charges instead of 3, then we can add all the electric fields due to n charges. So now this is the final expression in the summation form. So we have to add all the electric fields. As we are adding many electric fields, so we should know what should be the resultant of different vectors. So suppose two vectors are in same direction, then resultant will be addition of magnitudes of two vectors, and direction will be direction of any of the vector. And if two vectors are in opposite direction, then the resultant will be the difference of the two, and it is always larger minus smaller. Out here I have shown that A is larger than B, so I have written A minus B, otherwise I would have written B minus A. And the direction will be direction of larger vector because I am subtracting B from A, so A is larger, so the resultant will be towards the A. And if the vectors are making some angles like this, theta, then magnitude of resultant will be given by this. This is triangle law. And to find the direction, I have to use this formula. So beta is the angle made by the resultant with vector A. So now this is the first question. So there are 2 point charges separated by a distance 2 meters. So we have to find the position between the two charges where electric field intensity is 0. So I am considering two charges QA and QB. Let C be the position where electric field is 0. So let x be the distance of C from A, and this distance will be 2 minus x. So all the charges are positive, so due to positive charge, electric field will be away from the positive charge. So due to QA, electric field here will be in this direction. So I am considering it to be electric field at this point due to charge QA. Similarly, due to this also there will be an electric field out here, and the direction will be towards the left. So this is EB. Now the condition is saying the electric field intensity is 0. At this point EA and EB are equal and opposite, that's why the intensity is 0. So we have to find this x. So now this is the same diagram I am using. So these are the things which are given. QA is given, QB is given, so I am considering this to be 5 into 10 to the power 19 and this to be 20 into 10 to the power minus 19. AB is given, AC is x, and BC is 2 minus x. So if you give the names ABCD, then it will be easy for us to write these things. So electric field at this point due to QA will be given by K QA by distance square. Now similarly, electric field at this point due to this point will be given by EB, that is K QB by B square, and the direction, this is along A to C and this is along B to C, that is towards the left. Now I can use the expression of EA and EB to write this. Now when you put the values, now you can cancel this 10 to the power 19 and 10 to the power 19, and this is 5 4s are 20, so it will be, now I'll cross multiply, and now this 4 is 2 square, so I can write this to be like this. Now I can take this square and write root over this side. Now and when I cancel this and this, I should get plus minus 2. So when you take the root away, you should write plus minus. So there will be two conditions. If this is plus 2, we will have one condition, and if this is minus 2, we will have one condition. So if you take this to be plus 2, then you will get this x is equal to minus 2 meter. So minus 2 means your position is somewhere out here, so that is, it is not coming between q1 and q2, so this distance is not possible. So I have to find the distance in between qa and qb. X is equal to minus 2 meter goes towards the left of qa, so I cannot take this distance. Now let's take another condition, that is minus 2x. so this time you will get x is equal to 3 by 2, that is 1.5 meter. So this condition is right. So that means at the distance of 1.5 meter from qa, the x is distance from qa, so at distance 1.5 meter we'll have the electric field to be 0, because electric field due to a and electric field due to b will cancel each other. So now this is the similar question, you can try, but out here please don't write negative out here, because we are not finding the direction, we are only dealing with the magnitude, so you should not write negative out here. So instead you will write the negative like this. So the answer should come as 24 centimeter. You can try this question. And this is also similar kind of question. So out here instead of numbers you are getting q, q and a. So you have to find the distance where the electric field is 0. You have to do the same way we have done the previous question, and your answer will come as 2a. Distance will be 2a from charge plus q. So you have to mention from where you are considering the distance. So now this is the next question. 2 point charges are there and the distance between them is 0.1 meter, and we have to find the electric field at 2 points. One is midpoint between them and one is at some distance from this q1 and q2. So let's discuss. So first we'll discuss case number 1. We have two charges, distance is 0.1. so now I have to find the electric field in between them. So that means the distance will be half of this, that is 0.05. so out here at point C I have to find the total electric field due to these two charges. So this remaining distance will be this. So due to this the electric field will be towards the right, so EA will be towards the right, and due to this, because this is positive and from positive electric field is directed away from the positive charge, so out here EB will be in this direction. So now I have to find the resultant of this two. So now for second case we have the charges like this, and which is at 0.05 meter from Q1 and 0.15 meter from Q2. So this is suppose Q1, then from 0.05 is this distance, and from here this distance is 0.15 meter. Now out here electric field due to QA will be towards the right, away from the charge, and from here also electric field will be towards the right only, because this is also positive charge and electric field will be away from the charge. Now I have to find the resultant of this two. So now these are the things which are given, and this is the diagram, and we are doing the case 1, first case, which is the point is between the two charges. So distance is half of 0.1, so this will be 5 into 10 to the power minus 2 meter. I am taking this point 2 decimal places this side, so I am getting minus 2. So now electric field at C due to A. So electric field out here due to this charge will be given by this expression, and this will be along AC from A to C. So if you put the values, you multiply the numbers and take the power of 10 together, then you will get this. Now in standard form I have to take this point out here. 7.2 into 10 to the power 11 Newton per Coulomb is the unit of electric field. Now similarly electric field at C due to point B will be given by this expression. Now when you put the values, you will get 14.4 into 10 to the power 11. So out here I am not making it 1.44 because we got QA to be 7.2 into 10 to the power 11. So I should get 10 to the power 11 only, otherwise I will not be able to add or subtract them. So now out here I have got electric field, one towards this direction and another in this direction. Now we already know if the two vectors are opposite in direction, their resultant will be the difference of 2. So total electric field is EB minus EA. Why EB minus EA? EB is greater. This is 14.4 and EA is 7.2. So when you subtract this, 10 to the power 11 will come out. So you will get 7.2 into 10 to the power 11 Newton per Coulomb and along BC, because the direction will be the direction of EB and direction of EB is from B to C. So this is the resultant electric field at point C. Now this is case number 2. So distances are different. So distance of AC is 0.05 and distance of BC is 0.15. So I am writing the number in power of 10. So now electric field at C due to A. So formula will remain same. So I'll put the values. I'm getting this. Now I'll again make it 7.2. So 2 point this side means I have to subtract 2 out here. So you will get 7.2 into 10 to the power 11 Newton per Coulomb along AC. So it is going from A to C. Now similarly, electric field at C due to charge QB will be given by this expression. Now when you put the values, now when you solve this, you get this. Now I have to make it 10 to the power 11. So that means I have to take 100 out from here. So if you multiply 100 this side, you will get 160. Now you can see out here electric field due to A and B are in same direction. That means we have to add to get the resultant. So at point C, EA and EB are in same direction. So resultant will be given by EB plus EA. So now when you put the values and take 10 to the power 11 out, then you will get 167.2 into 10 to the power 11 Newton per Coulomb. And direction, you can take direction of anyone. So it can be either AC or BC. So but I have written BC. So similarly you can try this question. So out here 2 point charges are there. You have to calculate the electric field. So this is same question, only numbers are different. Out here 2 point charges are there. One is positive, one is negative. Now you have to take care of this negative. So don't use this negative in the calculation. Only you have to take care of direction of electric field. So you can try this question. So answer will be 900 Newton per Coulomb, and that is towards the negative charge. You can try this. So next question, there are two charges plus Q and minus 2Q, and they are placed at the vertices of equilateral triangle of side A. So we have to find the magnitude and direction of electric field in one of the vertices. So I am considering this equilateral triangle of side A, and these two are the charges, and I am finding electric field out here. Now due to this plus Q, electric field will be away. That means it will go from B to A. So this is electric field due to point QB. And similarly due to this, now this is negative, so electric field will be towards the charge. So electric field at this point due to QC will be in this direction. Now we have got two vectors. Now I can find the magnitude using triangle law, and this will be our final electric field. We have to find the magnitude of this and direction. Direction means angle with one of the vector. So this is the same diagram I have used. So out here I have not used negative in the calculation. It will make our calculation easy. So all the distances are A. So now electric field at this point due to charge at this point can be given by this expression. When you put the values, now this will be K and this is Q by A square. And similarly electric field at this point due to this will be given by this, and only charge instead of Q I have 2Q out here. So now I have got electric field due to this 2-point charges. Now I have to find the resultant of this two. So one is going this in this direction, one is going in this direction. Angle between them is 120 degrees. So resultant will be given by this expression. So this is the vector sum. I am not adding their magnitude. This is the vector equation. Now resultant will be given by this. So total electric field E will be given by this. Now when you put the values, that is cos 120 is minus half and other values. Now if you see out here, you can take this 2 out and make it square, and this 2 and this 2 will get cancelled. This 2 has come out, so this 2 and this 2 cancel, this 2 came out and this 2 square came out as 4. Now all the terms are like terms, so I can add and subtract. So I'll add this 2 first, and when you multiply this 2 you'll get the square. So out here, so 5 minus 2 is 3, and this is the like term. So now I can take this terms inside the bracket out because it's with square and root over will cancel. So total electric field will be root 3 kq by a square. Now this is the final electric field, and now I have to find the direction. For that I have to consider the angle made by the resultant with one of the vector. So suppose the resultant makes angle beta with EC or AC. So we know the formula to find the angle. So beta will be given by tan inverse, and out here we have to write the vector which is opposite to the angle. So the vector which is opposite to the angle is this one, EB, and our B will be vector EC and A will be our vector EB. So now I'll put the values. Sin 120 is root 3 by 2 and cos 120 is minus half. Now I can simplify this, so I'll take this 2 out. Now you can see this part is common, so I'll take this kq by a square common from the denominator. Now you will get this 2 minus half. Now this and this you can cancel because it's same thing, so you are left with root 3 by 2 and 2 minus half is 3 by 2. So I'll reciprocate and multiply this side. So this 2 and 2 get cancelled, and 3 and root 3 I'll get 1 by root 3. So now tan inverse root 3 means 30 degree because tan 30 is 1 by root 3. So beta is 30 degree. So this resultant will make 30 degree with AC. So in our previous questions I have written that this angle will be 60 degree by symmetry, but out here these two vectors are not equal, so the final angle will not be 60 degree. If the two vectors were equal, I would have written 60 degree without doing this calculation. I would have written the angle is 60 degree by symmetry, but as these two vectors are not equal, I have to do this calculation. So this is the end of the video. Please don't forget to like the video, and I would love to read your comments. Your comments will encourage me to make more videos. Please do write something on comment, and if you are new to channel, please subscribe the channel. And out here I'm giving my phone number. If you need help in any topic, you can WhatsApp me. Thank you.